Welcome students again into the 12th science chemistry class. We are learning from few lectures the chapter number first, that is the solid state, and into that in the last lecture we learned the packing efficiency of metal crystal in simple cubic lattice. Now today we have to learn the packing efficiency of metal crystal in body centered cubic lattice, that is the BCC. Now we know that in body centered cubic lattice one total complete sphere, that is the particle, is in the body, that is at the center of the body centered cubic lattice, and also the particles at the corners of the body center cubic lattice. There are the particles also, and we know that the corners particles contributes only the 1/8 part. Now here in this figure I show this central sphere, that is the particle of the body centered lattice, and the corners two particles are also shown here. Now the radius, we have to calculate the radius because we have to calculate here the volume of the body center unit cell, and also that is the volume of the particles, that is the spheres in the BCC. So for that we have to calculate the radius of the sphere, that is the particle. And in this figure we are seeing that this is the center of the sphere C, and these are the radius, that is this is the diagonal and these are the radius, and again that is the particle which are at the corner, this is the center. Here also this A is the center, here F is the center of this particle, and the distance from this circumference to the center, that is the radius. So first we have to calculate the radius. For that the radius of the sphere can be obtained from the Pythagoras theorem. Now what is the value of this radius? Now this radius can be calculated by the Pythagoras theorem, and for that let us consider the triangle FED. Now this is the triangle FED. Now this triangle FED is it is having the angle FED, that is the 90 degree. So this angle FED, which is 90 degree, FED, and therefore from the Pythagoras theorem the FD square, which is this diagonal, FD square is equal to FE square plus ED square. We know the Pythagoras theorem. Now in this FD square is equal to this FE square plus ED square, because this is the 90 degree angle here. This is the angle which is 90 degree, and therefore the FD square is equal to FE square plus ED square. Now see here, this is the body centered cubic lattice. Therefore the each and every, that is the length, breadth and height of this cube is, suppose this is A. So this also A, this also A, and this EF is also A. Now we have to calculate this FD. So substitute the value of EF as A and ED as A. Though the ED is here, you are seeing here this is small size, but that is not, because that is behind that lattice, three dimensional. So this ED also A. Therefore substitute the EF is equal to EF square as equal to A square, and ED square as equal to A square, because this FE is equal to A and ED also A. FE is equal to A and ED also A. So FD square, this FD square is equal to A square plus A square. That is twice A square. FD square is equal to twice A square. Now we have to here calculate the radius of this that is the particle or sphere. For that also we have to consider the another triangle here, that is ADF. Now this or AFD, ADF or AFD, no matter. Now this is also the that is the triangle which is having the angle into that. ADF angle is equal to 90 degree. This ADF angle is, this is also the 90 degree angle of this triangle. ADF, in this triangle ADF, the angle ADF is equal to 90 degree. So according to Pythagoras theorem, AF square is equal to AD square plus FD square. Now we already calculated this FD square, that is the twice A square. Then we will substitute this value into that. So AF square is equal to FD square, this, plus AD square, this. Now see here, this AD also A, because it is the length of the side of this lattice. So it is also A. So substitute AD square as A square. AD is equal to A. So AD square is equal to A square. And this we already calculated the FD square here, that is twice A square. So substitute FD square as the twice A square, because AD is equal to A. So this AF square is equal to A square plus twice A square, that is equal to thrice A square. Therefore AF is equal to under root of this, AF square is equal to F. F is equal to under root of this 3, and what is the root of A square? That is the A. So AF is equal to root 3A, this AF distance. Why we calculate this total AF distance? Because we have to calculate the radius, that is the R. Now you are seeing here, this AF is nothing but R plus R plus R plus R, that is 4R. And therefore from figure, AF is equal to 4R. And therefore here AF is equal to root 3 into A, and from figure AF is equal to 4R. Therefore 4R is equal to root 3A, because left hand sides are same. So right hand sides are definitely same. So 4R is equal to root 3 into A. And therefore R is equal to root 3 divided by this 4 into A. Now this is the value of the radius. Here in the BCC, the radius is root 3 divided by 4 into A. Now as we calculate the radius, now we have to calculate the volume of this total sphere and then volume of the particle. And then we calculate the packing efficiency by dividing the volume of the sphere by the total volume of the lattice into 100. That is the percentage of the sphere or particle we have to calculate. So let us calculate now the volume of this BCC first. That is the body center cubic lattice. Now pay attention students, again on a blackboard. We are calculating the packing efficiency of metal crystal in BCC, that is the body center cubic cell. Now in this step 2, in the first step we calculate the, that is the radius of the sphere from the two right angle triangles from the Pythagoras theorem. Now the second step, in which we have to calculate the volume of the sphere or particle. Now how we calculate the volume? We know the volume of the sphere, That is the formula of volume of the sphere from the 10th standard. What is that? 4 by 3 pi r cube. Now this is the 4 by 3 pi r cube is the volume of the sphere, and volume of the spheres means volume of the particle, one particle. So on substituting the value of radius, that is the r, which we calculated in the first step, what is that? Root 3 divided by 4a, that is the radius. Now on substituting the value of the radius in this formula of the volume of the sphere, we obtain the volume of one particle, that is the sphere. Now this 4 by 3 pi r cube. Now this is the that is the formula. Now here I substitute the value of this r as root 3 divided by 4a, which is the radius in of the particle in the BCC. What is that radius? We calculated first step, root 3 divided by 4a. So substitute the value of this radius in this formula as root 3 divided by 4a, and here it is bracket cube because here is the radius cube. Now on solving this 4 by 3 pi, now this is the root 3. Now here all have the cube. So root 3 cube divided, what is the cube of the 4? That is the 64. 4 multiplied by 4 multiplied by 4. That is the cube of 4. That is the 64. And here is the a cube. Now on calculating this, on solving this 4 by 3 pi, now this root 3 into root 3 into root 3. Root 3 into root 3 means 3 because the that is square root of the 3. That is root 3 into root 3, the square root, that becomes the 3. We know that. That is the square root of 9. That is the 3. And this root 3 remains as it is. Now you know that root 3 into root 3 into root 3. Now this 2 root 3, that is the root 3 into root 3 means 3 multiplied by 3, that is 9. And this is root 3. Now this square root of 9 is equal to 3 root 3. Now this is the value of cube of the root 3 is 3 root 3. So here I substitute this value of cube of root 3 as 3 root 3. Now this is the root of that is the cube of the 4, that is the 64, and this is a cube. Now again on solving this, now this 4 and this 64, when they get divided, the value is 4 into 4 divided by this 64, that is 4 divided by 64, 4 1 ja 4 and 2, that is the 4 6 ja 24. So this is this root 3 remains as this 3 and this 3 get cancelled here. Now 4 1 ja 4 and 4 6 ja 24. So here what is remaining? This root 3 is remaining, this 16 is remaining, this pi and this a cube. Now this is the volume of one particle or sphere. So volume of one sphere is equal to root 3 divided by 16 into pi a cube. Now this is the only the volume of one sphere. But we know that in body centered cubic unit cell, there are the two particles. One is in the center of the body and one that is the from the 8 corner, that is 1/8 part of each corner, that becomes also one particle. So there are the two particles in body center, that is the BCC. So total volume of the particles of the two particles is calculated by multiplying the 2 by this volume of one sphere. So the BCC contains two particles, therefore volume occupied by the two particles in BCC is equal to 2 into root 3 pi a cube divided by 16. And what will be that? That is the value of this, that is root 3 2 into root 3 pi a cube divided by 16. Now 2 1 ja 2, 2, that is the 8 ja 16. and therefore root 3 pi a cube divided by 8. Now this root 3 pi a cube divided by 8 is the volume occupied by the particles in the BCC. There are the two particles and their volume is, that is root 3 pi a cube divided by 8. Now we know the volume of the total unit cell, that is the BCC, and that is length into breadth into height, and all are A, so A cube is the volume of the total BCC unit cell. And then when we divide the volume of the particle by volume of the total unit cell, multiply by 100, that is the efficiency, packing efficiency of BCC. Let us calculate now the packing efficiency of the BCC. Now let us calculate the packing efficiency of BCC. Now in the fourth step, we know the total volume of BCC, that is the total volume of BCC unit cell is length into breadth into height, and all the three are A. So A cube is the total volume of the unit cell, that is the BCC unit cell. Now what is the formula of packing efficiency? So packing efficiency is equal to volume occupied by particles in unit cell divided by total volume of unit cell into 100. Now the volume occupied by the two particles in the unit cell we calculated, that is root 3 pi a cube divided by 8. That is the this root 3 pi a cube divided by 8 is the, what is that? Volume occupied by the particles in the unit cell. We calculated that, and this total volume of unit cell is this. So root 3 pi a cube divided by 8 into a cube and into 100. Now this a cube get cancelled here. So what is remaining? Root 3 pi divided by 8 into 100. Now what is the value of root 3? That is 1.732. If you see in that is the logarithmic table, or you can just see the log of the 3, divided the log of the 3 by 2 and then see the antilog of that. That is 1.732 is the value of root 3. The value of pi is 3.142, and this 100 divided by 8, if we calculate this, we can calculate by the logarithmic table also, by seeing the log of this and by subtracting log of 8 from that, and then seeing the antilog, you found that the value of this is 68%. That means the packing efficiency, that is the total volume of the particles in that unit cell, is 68%. Then what will be the empty space? 100 minus 68, that is the 32. That is the volume of the void. So thus in BCC, 68% is the volume occupied by the atoms or spheres, and 100 minus 68, that is equal to 32% is the empty space or void volume. Now this is the packing efficiency of the body centered cubic lattice. If student, you understand this very well, this topic, how to calculate the packing efficiency of the body centered metal crystal unit cell, then you subscribe and like this video, and also tell the another students of the 12th science to like and subscribe and watch this video. Thank you for watching this video, and you definitely success in the all the examinations which you have to face in your this academic year. So thank you for watching this video.